Good morning, everyone. Welcome to the webinar with Point One and ST today as we talk about some lessons learned in our projects on last mile logistics. My name is Michael Lepich. I work for Point One based out of San Francisco. Point One Navigation provides positioning solutions from the RTK signal all the way down to the software running embedded on your hardware. But to really unpack this, we've got two speakers today, Michael Slade from ST and Gabe Amancio from Point One. And I'll just hand it off to you guys.
Thanks, Michael. I guess I'll go first, Gabe. I'm Mike Slade from STMicro. I'm basically a technical marketing lead in the Americas for the Tessio GNSS family, and I've been doing this for 18 years. Actually, I've done a lot of work in algorithm development and application support and even marketing over those many years, and have worked now with the Point One team for 8 years. And before that, I spent 7 years at Motorola R&D doing software and systems algorithms for E911 for mobile phones.
Awesome. Thanks, Mike. Yeah, Gabe Amancio from Point One Navigation side. I lead our application engineering team here. I've been with the team for about 4 years now, supporting, as Michael mentioned, our different products, which include kind of the correction service, which we'll dive into today, but also the software that's embedded on, our customers' platforms at the end of the day as well. So, and then background electrical engineer coming from like the semiconductor space, also in application engineering kind of role where I kind of tune some of my skills for what I'm currently doing here at Point One. So excited to chat today. Tweet. And Michael, if you go to the next slide, I can kind of start introduction to what we're really discussing today, which is I guess we're going to talk about last mile, but really just kind of at a high level, talking about what ST and Point One together are able to enable. And that's really working with customers along the entire logistics life cycle. And what that entails is not necessarily only just the last mile, which is what we're going to cover today, but just knowing that at a high level, Point One and ST together via our hardware and software solution can provide precise location independent of whatever age we're helping in the process, whether that's actual ship containers at docks that are moving throughout docks, larger trucks that are doing middle mile logistics or that are actually now doing that autonomously, and then today what we're going to focus on, which is last mile, going from the distribution centers to the door, and how that interaction happens with the actual delivery driver as well. Awesome. So yeah, just kind of starting last mile, at the issues that they see at this kind of application is fundamentally a location problem, and we'll kind of jump into like what issues come from not having accurate location. But everything that stems from what we're trying to solve today comes down fundamentally to it being a location problem, whether that's the actual delivery driver that's having real-time positioning on their truck and having misalignment in the actual position, whether that's misalignment in the actual maps that are built up to actually know where these drivers need to navigate to, and then finally kind of the actual location issue of the driver going to the delivery location and dropping off those packages. So we'll kind of jump into how location is able to solve some of those problems. Great. This is really introducing why GNSS in the past, there have been difficulties in using it in some of these tougher environments, but we'll really jump into the solution in a couple slides talking about what ST at a hardware level really provides to enable clean signals for us to then process into our positioning engine and provide useful data, not only from the GNSS perspective when you have GNSS available, but also in the case where you are denied from GNSS, and what both we at Point One are able to provide from the software perspective, but also what ST is able to provide from a GNSS package that includes the inertials that we also take into our solution that provide kind of this level of accuracy independent of GPS. So we'll talk about some of those struggles on the GNSS side, but that is something that we at Point One and ST really focus on, is kind of enabling enabling this data to be usable from a perspective of enabling precise location. Sweet. And I think I'll kind of go to the first one, the first common challenge that we see, and then kind of work down this list. I've kind of brought up some of those topics already, but the first one being excessive distance from drop-off location. It may sound crazy, but as we're kind of bringing up this webinar and kind of what we've seen kind of across the market, it may sound crazy when we say, oh, well, excessive distance being 1 to 10 meters is actually an issue. But when you think about the scale at which some of these delivery drivers are actually going out and dropping off hundreds of thousands of packages per day, those inefficiencies start to add up. So those inefficiencies, this excessive distance from drop-off location, really happen at two levels. One being the actual mapping and enabling, how you have now this real-time data that you have storage and access to. How can you use that to actually build your maps for your delivery drivers to have more accurate drop-off locations, and then actually in real time also position yourselves within those maps. So we're able to enable that with precise location. The next one being location discrepancies between geofences and delivery drivers. So from some of the applications and the way that this is used that we've seen in the past, specifically for last mile, is a lot of times there's a hand device that's used when you go to actually deliver that package. This is a separate problem from the actual positioning of the van, but actually, having certain geofences, which can be an issue if those geofences aren't mapped correctly, or if the real-time position of that user that's supposed to be within that geofence doesn't have accurate location. So you can imagine if a device is reporting inaccurate location and you're actually within a geofence that you're supposed to be able to drop off one of these packages, you start to run into the issue of like, well, I can't actually locate myself in real time onto this map. Or I'm locating at a different location that doesn't believe it's within the geofence. And then all of a sudden, the delivery driver has to get in contact with someone that actually has access to the system and then enables them to actually drop off that package of where they're actually at the end of the day. It's just inaccuracies between the map and the actual real time. And then the last one is more of just a benefit of actually having this data, but it still kind of comes along with the last mile problem. And it's really the inefficient pathing between deliveries. There's having that level of granularity, even going down to like the centimeter level, lane level accuracy, and understanding over time what is the most optimal route for delivery drivers to go down. So that builds out like the mapping portion of like the actual real time physical location, but then to understand trends based off of that information. So like, going down this road at a specific time of day isn't efficient for our drivers. Let's think about, redoing this, re-optimizing this route, seeing how that changes the actual effect of that, and then be able to make decisions for, future drivers, depending on, how you see that data. So these are things that really are challenges that may not seem like huge issues, but as they compound across multiple, hundreds of thousands of deliveries, you start to see the benefit of, what we as STMicroelectronics can provide. And I'll just quickly talk here. I know I've been talking a lot. So sorry, Michael. I know we Slade. We have some specific ST slides coming up too. But what I just wanted to kind of talk through here. This is a recent demo that we did with STMicro at CES in Las Vegas. What you can actually see here is it's a little bit laggy, but on the bottom left, you're seeing the actual view from a dash cam that we have installed on the front of the vehicle. We're using the Tessio 6 solution that Michael Slade will be talking about, which is a GNSS receiver plus IMU combination. And we're showing real-time centimeter level accuracy on a vehicle that's driving around that we installed basically like 20 minutes before. So this is something that like we're able to install quickly from a development perspective, but really integrate even at high volume level. As you can see, this is us like turning into a parking spot right into that parking spot along that pole that you see in the video. So just at a high level, that video is kind of showing the level of accuracy we're able to really show in these kind of solutions on more of the delivery driver side, which is what we really want to focus on. But yeah, it's a really cool example of our technologies kind of working together between ST and Point One to make that possible. Sweet. So we're now going to kind of jump into not necessarily the but actually, yeah, we're really going to jump into like the solution of how both ST and Point One are able to provide this level of accuracy in the solution. So this is kind of block diagram level, like how we go about building that. It's not a ton of blocks, so that's a great start. But I'll let kind of Michael Slade start on the left side and kind of work our way down to the right as we, at the end, really provide precise location and PPT for our end customers.
Sure. Thanks, Gabe. So yeah, that video that Gabe just showed, I mean, that's the real deal. And all of that's happening because of all of these pieces and these block diagrams. And the Tessio 6, when it's working with the 0.1 PE and corrections, it's really serving the role of a measurement engine. And as you can see, raw measurements are transferred at 10 hertz, essentially, to their engine so that they can use all the signals that we pull in for their position created in all of those different environments. And like Gabe said, last mile is often urban and suburban. So there's occlusions, there's multipath, there's other things. So availability is so huge because the more signals you have to choose from when you are computing an over-determined position, and the more than you can essentially decide if they're not worthy, you don't use them. That's the name of the game. And the Tessio 6 is quad constellation, quad band, so that's what enables maximum availability for optimal performance, like he said, in all of those end situations. And the IMU, the ST IMU that feeds raw gyro and accelerometer data through that raw measurement pipe, is what they use for sure when there's complete outage. And that happens, of course. And, another little piece of information that's packed with all those measurements as well is the quality metrics. So signal and observable quality metrics that are provided that then they use to help kind of determine, hey, is this a useful signal? If it's not, then we won't use it for this period in time, and we'll revisit it. So,
yeah, that's a great point too. You made, Michael, too, about the availability on the Tessio 6. We see huge impact of obviously going from say like a dual band solution to the triple band or quad band. Just having that availability in these tougher environments is really important. And then to your point, the use of the IMU in our tightly coupled solution kind of enables us to do things like throwing out signal, like multipath detection using the inertials as well. So it's not necessarily only based off of what we're seeing from the GPS. It actually is coupled into what we're seeing from the IMU and expecting from the IMU as well. So we're able to leverage kind of both of those systems, both of those measurements within our software at the end of the day. And if you begin to the next slide.
If I can give you a brief overview of the Tessio 6, which is a new quad band, quad constellation solution out there. And as you see it, L1, L5, L2, E6, and B3I. So that's really just the full gamut of what's available today in the modern systems for GPS, Galileo, Beidou, and GLONASS, and even the others, IRNSS and QZSS. And so it's truly capable of pulling in most every useful signal available for performance at the same level worldwide. That's kind of the key. It's got 2 meg of embedded flash so that it's a pretty simple design. It's got enough channels to work anywhere in the world and leverage all the signals available in those spaces. We even do compute our own standard PVT as a loopback for the measurement engine. And in fact, since we're supporting B2B, B3I and E6, then, we're supporting what value they bring. And then lastly, it shows we're acquiring L5 independently of L1, and we can get into that a little bit later. So, just to dive in a little bit more on the measurement engine, I'll have another slide that goes more deeply, but it really, the key there is measurement quality. And just one thing before I let Gabe jump in, the measurement engine quality of the code phase and the carrier phase that's provided as a function of cost is kind of the key, metric these days for receivers. And there's been a lot of high-end receivers that have been doing this for a long time, and they're FPGA based, but they're not cost effective. So, we ST have come up from the other end of the problem, of the other end of the scale, trying to make a low-cost receiver that's continually more and more capable. So in this case, the number of measurements or signals available and the quality of the measurement noise is approaching, it's converging on what you would historically have been considered a survey grade receiver. And that's a great thing for the market and all the applications like this one for sure. So I don't know, Gabe, if you wanted to add anything to this.
No, yeah, I think that was a great description. I know, and Levis, I know there's another slide after this, so we can kind of at least show it while we're going through this, but that's exactly correct. From like our perspective as well, the cleanness of the carrier phase information is really what enables us to do our RTK technology. So having, a partner like ST that provides such clean measurements actually enables us to provide not only on the availability of like signals, but actually availability of like being able to use RTK corrections as well and enable that like centimeter level precision. So I think that's a really great point.
So yeah, and this is just a little deeper look at the measurement engine. As you can see in the upper left, the RF front end basically takes in the RF signals, down converts them, filters them, digitizes them, adjusts the gain even, and then passes them through to the baseband DSP, which is doing some more down conversion to 0 IF and filtering, and then actually puts them each into their respective channels so that they can be acquired and tracked, and drives the correlation process, which is what we use to decide when we say we have a signal and track. And that core processor and the DSP are kind of in a closed loop to execute those blocks below it, which are, the delay lock loops and the frequency lock loops for acquisition and track and nav data decode. And then, like I said, the most important thing that's running in parallel with that engine is the metrics and the calculation of the quality of everything we provide up so that they can use that and we can use that to decide, what's even happening to these signals. And then lastly, we do a lot of that with a weighted least squares and an extended Kalman filter. And you can see the one bar below that, which talks to safety, integrity, and security. And, you probably heard a lot about these terms, and I could talk about these, in great length, but they're so key to these receivers these days because anywhere these bands operate, you need to have the secure and high integrity in that information you pass, so that there's no way it can be compromised, especially in these bands, which are typically autonomous or partially autonomous. And so you really have to have that. And I'll get into some of that in detail on the next slides.
Yeah, and I think thanks, Mike. I think that's perfect too, because we'll kind of jump into like the safety and the different tracking and acquisition topics at the end of this as well. We're going to talk about RTK corrections, which is provided by Point One. I think we've kind of dove pretty heavily into the PE at like a high level, but at the end of the day, just to kind of bring that back, it's a fusion of the raw measurements that are being provided by STMicro. So the raw GNSS measurement, the MSM messages that we're expecting, alongside time-stamped IMU data, typically to the GPS time that's associated to the actual GPS data. And then we actually fuse that within our filter alongside RTK correction data to give you position independent of GPS. We'll obviously more heavily rely on it when it's available, but the goal is to make sure that we're at least providing PVT alongside, variance in that position and attitude over time. But we're able to do that kind of from one of our, our core inputs to that is our RTK corrections network. So you see that circled there. Leverage, if you go to the next slide, I've got a little bit on our RTK network. Us at Point One, we've really focused from the start. Slade kind of mentioned that he's worked with us for about the last 8 years or so. At a core, we've really focused on building out an OSR first network. And what that means is everything that you see on this map on the right, and I think it's been actually updated since then as we're always deploying base stations. These are all of our own infrastructure. We actually build our own base stations with high-grade receivers, high-grade antennas, battery management system, dual SIM to enable as much uptime as possible. But we actually work on deploying these ourselves over the world. I think we're close to like 3,000 of these now. Where we actually own the infrastructure, and we have the whole back-end process for surveying those base stations, making sure that we're continually surveying those. So as the Earth moves, we're aware of that. But we've focused at a core of this OSR first type of network, which is actual physical base stations, which at the end of the day will provide you the highest level of accuracy. We do have also what we call like a virtual RTK or an SSR based network, which is like a model that basically enables coverage everywhere, but then you are sacrificing things about like accuracy and then typically your time to first fix. So at a core, us at Point One, to enable our positioning engine, really focused on this OSR first approach. We're always working on having coverage that really enables like 3 centimeter level accuracy, which is about like 4 kilometers, 3 centimeters 2D, to kind of be clear about that. But we have really focused on enabling that even at the furthest baseline that we provide to customers. That goes to the second point, best level of accuracy with most dense. Again, we really pride ourselves on not only having a lot of base stations, but actually covering land mass as we do that. It's easy to have a lot of base stations in one area. It's hard to do that across a large area. So we really pride ourselves on the ability to do that and also continue to scale that kind of arm of our network. We're building about like 100 base stations per week or more, deploying, about half of those that are built per week as well on that, like next week or 2 weeks. So we're always expanding and working to make sure that we provide the best coverage for our customers. And the last point is, produce, manufacture, and deploy our own, designed by ourselves internally as well. Sweet. So this kind of goes back into bringing up those common challenges again. We just kind of bring them back. The excessive distance is one we talked about for the mapping and real-time perspective, location discrepancies for geofencing, and then inefficient pathing. Michael, if you go to the next slide, it kind of jumps into the solution space a little bit. So we've kind of talked through it already, but one of the things that we really see is the optimization of limiting distance from where the vehicle actually stops. One is like actually being able to optimize maps to know like this is exactly where I should stop down to like lane level, actually like centimeter level position on the van in order to like limit the amount of time the person actually has to be out of the vehicle. So from the van's perspective, it's both the real time and the ability to use those locations to build out your maps for these areas that you're delivering at. The next one being the accurate geolocation. This is more on the handheld level, so thank you. This is, we can actually jump to that, Michael. And then we'll jump back to this slide. But this is a real world result use case of like someone using a device that actually is on person. So it's like a small ceramic patch, obviously packaged antenna, about like 30 millimeters. The parts that you see that are not at the bottom right corner where you see that huge cluster are actually our position solution along with attitude. in a vehicle, actually. So it's receiving signals still within the vehicle, able to provide a solution. That's not the level of accuracy you would expect from, an antenna that's on a van, which you can kind of leverage both of these systems in order to provide position dependent on like what the platform is. But this really shows the level of accuracy also when you get out of the vehicle. So at the bottom right, it's kind of like a real world example of like someone getting out of a car, where that green portion is. That's where it actually goes into like an RTK float solution is what we call. And then walking to the actual door to the left of that, and just showing the repeatability on like a receiver antenna that like traditionally has like not enough signal quality to be able to provide this level of accuracy in the solution. This really shows that like, even at the level of wearables, which is like a lot different than like, an automotive vehicle where it's easier to give this level of precision, we're actually able to kind of give like porch level, I call it porch level accuracy of drop off locations in real time and consistently. So then you're able to, again, like that geolocation problem, being able to build your geofences more accurately is actually going to positively affect your actual delivery driver experience as well. So this is just cool real world example that we took here in San Francisco, along a building that's like 25 30 stories or 25 30 feet high. So it's also has like occlusion of signals during that point in time and all of that as well. So just wanted to kind of give a real world example of not only the car, which we showed the video demo of, but also where we're, like I mentioned, able to help kind of along the whole chain. And Michael, if you go back up one slide. Awesome. Yeah. And then the last one, again, just route optimization at scale, kind of ties to the first point as well. But just understanding traffic patterns more, even down to the lane level, which is I think a key differentiator of understanding. Like it sounds crazy, but the time associated at the scale of some of these logistics companies, it really makes sense to really look at that. So yeah, that's how we're able to solve point one and ST together, kind of that problem with that architecture that we just described. The positioning engine side, I guess I didn't mention. There are ST processors that are out there that like we support today and are able to integrate very quickly in the case of wanting to go down that route. But we have programs that run on host, any Linux processor we're able to kind of integrate into. So we have that flexibility whether you want like a modular approach versus something a little bit different, which ST is also a great partner in that they're able to provide module level versus chip down at scale in order to really help customers scale.
So yeah, just to kind of put a little more context to what Gabe said that the receiver's doing to help, because for sure in these last mile delivery vans, there's probably jammers inherent in the vehicles themselves just due to some of the technology that has been going into these higher, more sophisticated vans, especially if they're autonomous, like display clocks and camera clocks. So it's conceivable that your biggest jammer for your receiver could be in your vehicle. And so this key feature of trying to use whatever signals it can and not depend on all the signals collectively is a really valuable mechanism. And then having monitors essentially to detect what's happening in the bands and deciding what to do and what to pass and what to indicate upstream to the positioning engine is also key for them to make sure, like Gabe showed in that plot, that you don't have, crazy outliers. You didn't see any outliers on the other side of that parking lot because this is all happening in integrity. And it kind of, I don't know, how do I say, sometimes isn't understood because if it's not seen, it's not well understood. And then, of course, sometimes there's external sources that do jam. So anti-jamming, which has evolved in our receivers over the generations, has become extremely sophisticated and valuable in making these autonomous vans, their positions bulletproof. I should say their measurements bulletproof. You can move on to the next one, Michael. And, with jamming, as you've heard probably a lot about spoofing, maybe not as prevalent as jamming, but in certain areas of the world, for sure. So you definitely want to make a product that's viable worldwide. And so the anti-spoofing intelligence in the Tessio 6 also has evolved over many generations, and some of it's open even, like the OSNMA. That's the last bullet down at the end. If you're familiar with Galileo's, you know, um, nav data segment that's in the E1B message, that's a nice way for anybody to leverage it for verifying the Galileo position compared to positions computed with other constellations or the total computed position. And I'll go back up to the second bullet because that's also a really key one where we look at the correlation peak and we look at it very closely, and we have dedicated channels to zoom in on any correlation peaks that we think might be questionable. And for sure, these are proprietary methods we've developed, but it's a way of analyzing and quarantining what we suspect may be a spoof signal and not including it. And that's also what gets passed up. We may clarify for the positioning upstream that, okay, for the time being, these signals are not ones to be considered. And lastly, we do our own little computation of our position, standard position on our chip, just to kind of use it as another means. And that information is also passed, but really the 0.1 PE is so well developed and mature. It has also those same and then some capabilities inside it. So Michael, you can move on to the next one, please. And then security, I mentioned before, anymore, it's really not a viable product if it can be hacked or if it is not secure. I mean, in this ISO 21434 standard was created because of the concern worldwide of the ability for vehicles to get hacked. And well, when they're autonomous or partially autonomous, and there's not someone there to help counteract it, it even becomes more important. So these features like secure boot and firmware upgrade and secure comm and even on-the-fly decryption prevents them being hacked. And these are features that evolved from Tessio 5 to Tessio 6 and are being actually surprisingly a large percentage of our new customers going online with Tessio 6 now are taking them because they see the value there. So that's something I'd be glad to talk to anybody about further if they're interested. So you can move on to the next slide, Michael.
Yeah, I think this one kind of hopefully kind of summarizes what we kind of can bring about solving the hardest parts of last mile delivery. Traditionally, if you're using a similar technology that is reliant on GPS, like you would in most vehicles at this point in time, when you're relying on standard GPS, in these cases, you may have 3 to 5 meter accuracy depending on what environment you're in. It may be better in open sky, but as Michael Slade mentioned, usually you're not delivering necessarily in a super open sky environment. You may, but there's usually tougher environments, which we kind of talked about in that second point, that you're delivering in places that may be in urban canyons, large complexes, university campuses that really make for a challenging environment to actually go and deliver. But this solution really solves a lot of those issues that you see kind of come about. And the result, again, is not only happiness from the receiver's perspective, but less wasted time, failed deliveries, and actually less unhappy, I say customers, but actually like customers who are actually using the positioning products. So drivers that are out there that are using their van every day, going up to doors and making sure that they're actually at the place that they want to be and want to be to drop off packages. So that's what we're able to do as a partner with ST and Point One is provide that. And I think on the next slide, we kind of just mentioned if you have anything that you want to talk about, we can kind of start here in the Q&A, or we can talk offline about what your location problem is and how we can solve that together.
Well, thank you, Mike and Gabe. Man, I love emceeing a webinar where I learn so much. This has been a really meaty topic, pretty thorough content. I do want to go to some of our open Q&A. We've had a couple of great questions. Some of them are very practical, and then we also have some fairly technical ones. On the practical for you, Gabe, Timothy asks, can we add our own RTK stations? We move stations as needed. I will be serving remote locations as task requires, such as remote north and islands and near and offshore.
Yeah, I'm happy to answer that. So how our network currently works is we typically only use our own base stations due to a couple different factors. One being the visibility that we have both from a power and cellular perspective of making sure the base station's up as much as possible, and also having the monitoring to do so. And then additionally, like the complexity of like having to look at stations that may be moving is also something that it being a part of our core network makes difficult because everyone that's a part of our network can connect to these base stations. So that's like another thing. And then sometimes as well, it comes down to like the quality of the base station as well. We are technically able to analyze and walk through that process. We have a backend system that does it for our own base stations. But then there's a complexity of like having to do that for every new base station that we would then want to ingest. So it's just not our typical flow of how we go about doing that. I guess to note though, you move between different locations. What we do at Point One is we have what we call like a global network that like independent of what base station you're connecting to, they're all surveyed to the same datum and epoch. So you independent of base station, you should be aligned to the same reference frame. And if there are challenging areas that we don't have that level of coverage already, that's something that we're happy to talk about. We typically most of our base stations are put out like we schedule it, have LAN partners that we work with to actually get our base stations where we need them to be. Those are longer term plans in order to actually do that, but we also actually work with customers to deploy our own base stations. It has to be a private location that has good sky view, and we verify all of that with customers. But we actually will support that for like quick turnarounds on making sure that you have coverage wherever you need. And that's we call it like our deploy on demand. We do support that for customers that are actually subscribing to the data side. So hopefully that answers most of that question.
Yeah, let me move on to the next one. A little bit of time here. Scott, you guys can bend backwards. How does the solution with intermittent or periodic use, like for low power shipments tracking? Are there features here that improve cold and warm fix performance?
So that's for me, I think. So yeah, the Tessio 6 is not optimized, I would say, for intermittent periodic, like super low power tracking. We have other solutions for that. This is primarily a high-end precise position offering. So I guess, Scott, if you want to chat offline, we can, and talk about what's a better fit. And I guess really what your accuracy requirement is, that would kind of dictate what would be the right thing to mention. But I do want to mention, you asked about features here to improve cold and warm fix performance. And one nice thing maybe you're familiar with is that the B2B signal has a 3-second nav data loop, and it enables cold start fixes in the 12-second time frame. So in that case, you're improving greatly upon what's historically a 25 to 30-second typical cold start with the other constellations. So that's also something we could talk about to help you understand if if that in and of itself could be of value to you to improve cold starts. So thanks for that question. Very good.
Okay, great. Let me move on to Joe's question. How do you decide when to use IMU and together and when to decouple them? Are any specific algorithms you can disclose here?
Yes, not in the minute we have, but I can. Yeah, that may be a bigger conversation, and there's some things that I can't disclose, but in, I guess, just like a high level, in most open sky environments, we're typically always relying on the RTK GPS data, but that doesn't mean that we're not using the IMU data. I kind of mentioned we have a tightly coupled versus like a loosely coupled solution, which basically allows us to do things like integrity checks, kind of like on the hardware side, but from a software perspective of like, if I know that I move forward 1 meter and I know what satellite should be above me, but the IMU is telling me that I didn't move that way, or something to that effect, that will actually trigger some sort of failure within our own engine, an integrity fail. That doesn't happen because the data that's being provided is great and it works, but we're actually not ever not using either sets of data. We're always continually using that in our position solution.
Okay, that was, I think we're at time. I'm going to go ahead and show this slide here with the QR code. We will save the chats and the Q&As, which, wow, it's just like pretty big backlog here, and follow up with them after today's webinar. Thank you all very much for joining us today. This is just a real great deep dive on some of the challenges in last mile delivery and in RTK-based precise location. Thanks for joining us and look forward to seeing you on the next one. Have a great week.
Yeah. Thanks, Gabe. Thanks, Michael. This has been fun.
It was really fun. Thanks, guys. It was a good one. See you all.